Hello, you absolute legends. My name is Don Cavanaugh, and we're going to talk about a lab and some calculations for getting the formula of a hydrated ionic compound. This is an ionic compound with a metal and a non-metal, and in solid state, the crystalline structure incorporates a number of water molecules. We're going to talk about the experiment and the calculations to understand how many water molecules are integrated in the crystalline structure of an ionic compound. You need to have a watch glass that's labeled somehow uniquely, and then you're going to weigh out about somewhere between 0.5 and 0.8 grams of the hydrated salt. Write the mass down and then put it on your watch glass. Put your labeled sample in the oven. Wait about 10 minutes. After 10 minutes, we're going to take our sample out of the oven using a glove if necessary. And we're just going to lay it on the side here to cool. Now we're going to weigh the amount after the first heating, and we should absolutely get a value that's lower than what we started with. All right, we did. We have lost some water due to heating. We are going to do a second heating to double check. After the second heating for another 5 minutes, we're going to re-weigh it and see if it should go down a little bit, but hopefully only just a little bit. Back in the oven for the second heating for only about 5 to 10 minutes this time. For the second heating again, take it out carefully with a pair of gloves and lay it to the side to cool. After a second time in the oven, we're going to mask the sample again. The second heating we expect to be lower as the sample will be drier, but we also expect it to be close to the mass of the first heating. Here is the data you should have collected during the experiment. The mass of the hydrated salt, the mass of the salt after the first heating, and the second heating. We want these numbers to be close to each other to tell us that it is fully dehydrated. 0.42 grams is the mass of the anhydrous salt that remains, and therefore 0.24 grams is the grams of water that was driven off. 0.42 plus 0.66. The difference must be 0.42 grams of water. We have the mass of the water that was present in our original sample, and we have the mass of the anhydrous ionic compound that was left behind. To find out the ratio of water molecules, we cannot compare the ratios of grams to grams. This would give us a ratio that is not correct. We want to compare the ratio of moles to moles. So let's convert both of these numbers into moles. So water, I happen to know the formula for water, like memorized off the top of my head. And if I want to solve for moles, I better start my scaffold with moles on top. So that's not going to work. That'll solve for how many moles of water are present. For the moles of the anhydrous ionic compound that are present, I would add these up and solve for moles. So this is adding up the copper, chlorine, 2 of them, and writing them in right there. These are the results of those little scaffolds. 0.24 grams of water equates to 0.013 moles of water. our anhydrous ionic compound, CuCl2, 0.42 grams of that corresponds to 0.003 moles of copper chloride, the anhydrous ionic compound. The ratio of these will tell us how many water molecules were present inside of that crystalline structure. This ratio will tell us what this coefficient should be. Now note that this ratio is not going to come out to a whole number. Can you have a fraction of a water molecule incorporated? How would you round that number? Is it intelligent to round this to the nearest whole number, up or down? I hope this helps. Thank you.